Welcome back to Breakout 2. Our next talk is by Tyler Warren and Caleb McDonald. They're presenting AWS Data Perimeter at USAA, things we knew, things we thought we knew, and things we think you should know. I'd like to thank our sponsor, Chaser, and their product Discriminate. Discriminate Firewall is a transparent NAT gateway alternative with egress filtering and monitoring. It allows product teams to discover and update narrow allow lists for their apps' outbound connections easily. If you have any questions, we'll have 5 minutes for Q&A after this. Please welcome Tyler and Caleb.
Hey folks, welcome. Like I said, I'm Tyler. I'm joined by friend and coworker Caleb, and we're going to be talking about our data perimeter journey over the last several years at USAA. As you might imagine, based on the title of our talk, we're going to walk through 3 different themes throughout the presentation. The first is kind of what we implemented, our assumptions at the time based on all the available public documentation, all the available public resources. It might be, edge cases that we had assumed and things that we wanted to account for originally. But as we got into it, we've had realizations. There are assumptions that we made that were incorrect. There's misconceptions or edge cases we didn't think about as thoughtfully as we should have, and resulting in strategic mistakes that we hope that you avoid. And so leaving this presentation, we hope you have actionable takeaways, maybe different ways of thinking, maybe different thought processes that you should engage in order to have a more successful data perimeter experience in your journey. As always, context is important. So you're going to be hearing throughout our presentation things that are unique about USAA, our regulatory environment, as well as some company culture ethos that we believe in. USAA stands for United States Automobile Association. We were started a little over 100 years ago. We offer members of military and their family banking and insurance products. We'll do between $30 and $40 billion in revenue this year. So we're a sizable company, and we're about 5 years into our AWS journey. And with that, I'm going to turn it over to Caleb.
Thanks, Tyler. Hey, everyone. My name is Caleb McDonald. I'm a cybersecurity architect at USAA. I'll be covering a couple of our sections today on the presentation. The first is going to be defining zones of trust within AWS organizations. So AWS organizations is really kind of the foundation of the data perimeter concept. It's where you deploy your accounts. It's where you're going to be pushing, your policies, SCPs, the associated IAM roles, and of course these condition keys that are so important for the data perimeter. One of the early questions and really one of the recommendations we have is aligning your data perimeter with your organization's zones of trust. So, of course you want to protect against external identities, sending data to unauthorized external resources, but you may have reasons to implement what we'd call like internal zones of trust as well. And that really, brings the question of what zones of trust are most important for your organization and industry. And so we've got a lot of different companies here. So you may be in a highly regulated industry, maybe financials, healthcare, government. You may house customer data from these organizations and enterprises, or you may be in an organization and an enterprise that you have a little more, less regulation, less standards, and so you can kind of define your own zone. So with that said, just some examples here to consider are, just generally, let's say you're not highly regulated. You may look at things like lines of business where you want to focus on confidentiality, integrity, availability. Human resources would be an example of an area that data may be a little more sensitive. It may be data that you want to add those extra internal and external protections for. Environments is another example. Production and non-production, very common example is a lot of times our lab environments, dev environments are a little more open in terms of what we allow developers to do. So you may want to ensure that a non-production identity can't make a connection inside of a production data set and pull that data into a non-prod environment. Data classification is another example. You may have a very mature operation on your data origination, lineage, data classification, sensitivity, data types. It's another way to build your internal zones. In financials, PCI DSS is a really obvious and good example of a place that you may want to go the extra mile, build zones of trust there and secure that environment, and privacy with GDPR, healthcare with HIPAA, and it just really depends on what's important to your enterprise. So with that, a couple of recommendations here is ensure the zones of trust are communicated and well aligned with key stakeholders. That's going to be examples would be like your security teams, your compliance teams, info risk teams, any governance teams, and any highly regulated business units you have. And really that kind of leads into at some point, you're very likely to cause impact to your developers and their delivery with these capabilities and these zones of trust, whether it's a preventative control that's preventing, a test that they're wanting to run from crossing those zones of trust and those boundaries, or if it's a detective control and you've assigned a ticket with an SLA, maybe like you would a vulnerability for a team to go fix. And so ensuring that you're aligned with your organization's goals and your key stakeholders makes that messaging, a little easier and allows you to scale out the operation. And finally, defining zones of trust for which you can realistically achieve success is going to be really important, especially in the cybersecurity world. It's really fun to think about all the sophisticated ways we can do segmentation, especially when you're talking identities, networks, data, applications. But you can also go so far down rabbit holes of segmentation, micro-segmentation, that you may find yourself spending more time trying to maintain and keep up with your own policies than if maybe you had simplified those zones of trust a little bit. So ensure that whatever you define, you can achieve realistically with little impact to your operations teams. So we've just talked about, kind of really what are your zones of trust? Of course, you have the external world, then asking the question, what zones of trust are important to your organization and the industry that you're in? Now we're going to talk a little bit about, once you know what that looks like, you know what zones of trust you want to define, how can you structure your AWS organizations and your organizational units to simplify the management of this moving forward? If you're like us, you probably start out with a few AWS accounts, you start making the investment, you see the value, that grows, and here comes more accounts. And so, for us, looking at how we manage access between accounts, especially from a data perimeter perspective, has evolved over time. And so in this example, we've got an AWS organizations deployed, and we're going to use a company as an example that has a supply chain line of business and, in fact, a manufacturing line of business. This company has decided that, those are two different zones of trust. They're implementing their zones of trust based on line of business. But as is the case, I think, with a lot of scenarios, you're going to find the need to cross those zones of trust and those organizational boundaries from time to time. And so example would be supply chain's going to need asset data from manufacturing. They're going to need inventory data and production data. So in this first example, we've got our two organizational units, and we're managing connectivity between the supply chain accounts and the manufacturing accounts at an account level. And you can see there the condition is for any value string-like, and we have a resource account and principal account. So, this implementation's pretty effective from the standpoint that it's pretty granular, and you're getting down to the account-to-account level. But this can quickly get out of control, especially as you grow your accounts, you grow your investment in the platform, and you deploy more applications. This can quickly become a little bit of a management nightmare. So now we're looking at the same concept, but you'll notice under both the supply chain OU and the manufacturing OU, we've added an additional layer of nested organizational units. So supply chain, we just have kind of generically department 1 and 2, but under manufacturing, we've added shared services and data. And so really this is the concept that the organizations looked at their overall deployment within manufacturing and said, I have a set of data, I have a set of applications that I know I need to share with other lines of business. And so they built the organizational unit around that. So this simplifies the implementation and the management. If you look at Department 2, and let's say this is SCPs and VPC endpoints with condition keys, we're now able to implement AWS Resource Org Paths and AWS Principal Org Paths. And at this point, we've essentially deployed those VPC endpoints, we've deployed the SCPs, we've got the condition keys that allow this cross zone of trust, this cross OU access, but we're not managing it at a fine-grained level. We can, to a degree, set it and forget it, and just allows more operational efficiency as you continue to scale out. So we're going to look at one other view of this capability. So you'll see it's the same setup we had in the previous slide, but under the manufacturing organizational unit, what was the generic nested organizational unit is now control systems. So we're talking about now a group of applications and data that are going to be highly protected with an organization, right? So not something that you want just anyone being able to write their own resource policy or endpoint policy and be able to connect to. And so another way to look at your zones of trust within the organization is, what do you want to implicitly deny access to? Maybe this company, that's all they have within their AWS platform, supply chain and manufacturing, and they said, I'm completely good with any application in my supply chain connecting into my shared services, sharing data within the manufacturing org, but I have this set of applications, this set of data that is extremely important to me, it's extremely critical, and I need to ensure isolation. So from this perspective, we're using the condition keys for any value string not like, and that's really where you can follow it up with string equals, like in this example, principal org ID, resource org ID, but what you're really saying here is I'm going to allow you in the supply chain to connect to anything within our org, but I'm going to restrict specifically this nested OU. And that kind of gives you that like very restrictive isolation. And what you'll find is you can kind of mix and match these approaches as you start to look at what I would call almost like a zone of trust connectivity matrix, where what's important to your organization, where do you need to allow exceptions, and really the goal is you want to simplify management by grouping like things that you want to allow access to, shared services, shared data, or you want to group like things that you want to restrict access to, things that are highly sensitive, that you want to ensure it's extremely least privileged to get in and out of that zone of trust. Okay, so we recommend architecting your organization to simplify management of the zones of trust, condition keys, and exceptions. And just a quick point on infrastructure as code automation. Our zones of trust, and specifically our views on shared services, shared data sets, how we group those has evolved absolutely over time. And we're really looking to simplify the way we're doing that, whether it's like, kind of global, if you will, shared services, line of business shared services. The investment in automation as code that we have an incredible public cloud security team that's a DevSecOps team. Early in our journey, we invested in infrastructure as code, and that's allowed us to be very operationally efficient and allow us to really scale without, creating new accounts, creating new OUs, being too much of an impact to the team. So infrastructure as code can certainly provide a big value and return on investment over time. Okay, so we're going to take a little bit different look at some of the considerations for Data Perimeter now. So we just talked about really what are your zones of trust, what matters to your organization, how do you structure your organizational units to meet those goals. But there's a very good chance this topic could extend beyond just AWS for you. If you're like us, we were a very old organization that has on-prem data centers, co-location data centers, and cloud was an investment we made where we became a hybrid enterprise and hybrid network. We evolved that way. Maybe your company was born in the cloud, but mergers and acquisitions have all of a sudden now you find yourself in a hybrid enterprise scenario with hybrid network connectivity. And so we would like to touch on a few key considerations here when you think about your defense in depth architecture and your hybrid enterprise. So this is an extremely general representation of what the AWS Data Perimeter does for you. But here we have our AWS account. We have our AWS resources, and access to those resources. We want to ensure that only the identities that we trust can access those resources. And we want to ensure that those identities are coming from networks that we expect. Down in the bottom half of the diagram, we have either like service roles operating on the service plane, or maybe you have an application services with application roles that are, traversing your VPC and your VPC endpoints. And you want to make sure that those identities can only interact with trusted resources, and it's your identities and identities you trust coming from your AWS environment. So it's a pretty overall, I don't want to say it's simple to implement the data perimeter, but you are getting a lot of defense in-depth controls that AWS is managing on your behalf as part of the shared responsibility model. There are scenarios where your data, either outbound or inbound, may indeed leave the AWS platform and traverse systems that you are still responsible for securing. You're still responsible for the security control of those systems. I've got a few examples in the data center colo box there. That could be like non-AWS destinations and resources, non-AWS sources, identities originating, from outside of AWS that maybe are traversing and entering your enterprise before they come across your hybrid network. Cross-region requests by default aren't going to use a VPC endpoint. There is a transit gateway architecture that allows you to address that, but not everyone's going to make that investment. And then finally, of course, AWS services with no VPC endpoint. Now you may be invested in an AWS internet, outbound and inbound stack, but this is kind of looking at the fact that for a lot of people, they may be multi-cloud, they may have colos that are regionally located to multiple cloud platforms, and they could be centralizing those inbound and outbound capabilities in those colos as well. And so over to the left, we have some, we recommend analyzing hybrid controls and capabilities. This is not an exhaustive list. Defense in-depth architecture, there's a lot that goes into it, but we kind of wanted to highlight a few things that relate to the goals of the data perimeter. So, only trusted identities, things like digital certificates and key pairs and MTLS, for your authentication, API authorization. Those are pretty simple policies in cloud native and AWS. Or, are you looking at implementing OAuth? And then, of course, how are you managing the secrets for all these authentication capabilities and authorization capabilities? Next, let's look at only expected networks. So, example would be there's an SCP that you can implement in AWS that says if you're interacting with my resources, I can set a condition key that says it's only from networks I expect my principals to be coming from. So if you had a secret stolen, someone's all of a sudden using your identity, token, and secret from a network you don't expect, that is a preventative control you can implement there. Let's go to like a colo world or the on-prem world, things like network access control list or network segmentation with your firewall, or maybe you're doing B2B and you can say my B2B partner, I expect them to be originating from this CIDR range, these NAT ranges, that you can kind of implement that same only expected networks. MTLS is another way to do that. Some of the ranges are dynamic in the cloud, and so predicting what ranges business partners come from has changed a little bit. So with MTLS, you're authenticating not just the server but the client as well. Only trusted resources, things like URI filtering are really good for that. You can go least privilege on your outbound for your application services and really say, I'm going to have like a zero trust outbound, and it's only when a URI is expected and I know the resource is either mine or it's an authorized resource that I'm going to allow the connectivity. And then finally, we just got a couple examples of your common like infrastructure, security, encryption in transit, denial of service protections, malware protections, WAF, botnet mitigations, the list goes on, and then logging as well, of course, to integrate with your SIEM. So that's really it. Before I hand it over to Tyler, just really to say that your data perimeter in AWS, unless you're only in AWS, is likely part of an overall defense in depth architecture. And so be keeping in mind, what are all your zones of trust, what matter to your organization, and how are you achieving that with your architecture. So thanks, and I'm going to turn it over to Tyler now.
So if I were to ask people, what boundaries is your data crossing in your organization? The answers might vary. Some of you might know exactly. Some of you might not really know at all. And there is a lack of telemetry and analytics available when actually trying to survey and gather this data. So one of the places that we really chose to invest is enriching all of our CloudTrail data with metadata about our accounts. That includes things like the account tags. That includes things like tags for governance processes. And as a result, we can tag API calls with the boundary that they cross. And so it's with that kind of information that we were first able to determine where to start. And that is S3. 85% of the outbound calls crossing our organizational boundary were to the S3 service. And so knowing that that's the service that we most heavily used, also knowing our business and knowing that that's where our most sensitive assets live, that's where our crown jewels are in S3. There's probably a lot of you out here who could say the same. We chose to invest in kind of ensuring that we had not just our external organizational boundary as part of our initial rollout, but our production OU. That's where all of our sensitive data is. We want to ensure that that data cannot be exfiltrated to lower environments where your controls are typically a little less restrictive. I do want to note that for the two AWS-based vendors, the trusted and untrusted org, our primary mechanisms for controls there are SCPs and VPC endpoint policies. But like Caleb mentioned, if you are doing business with a service or a partner that is not in AWS, or maybe the service does not support VPC endpoints yet, you're going to take your default network path through your, hopefully, company-owned security stack. So whatever controls you start to implement in your cloud environment, make sure you have comparable controls implemented in your on-prem environment as well. One of the things that we started to see as we matured is the rise and the growing number of what we're going to call shared services. These are things like maybe golden AMIs that you share across your accounts that you require your application teams to use. They might be core services that take care of some of the networking stack. They might be things that you use for tokenization across your org. These are things that every account might need to access at one time or another. And so you can see by this diagram, you're going to have to make exceptions for those non-production identities to take advantage of those shared services. And so the risk there is that the amount of exceptions as you grow in scale and footprint, those become unmanageable and unable to lifecycle. It's one thing to implement an exception. Do you actually go back and remove it when you don't need it anymore? Many times, no. The other thing I would point out, and this is really key, is that those shared services for hybrid organizations are not just shared services you use to impact and service your own cloud environment. You might start to move on-prem applications into your cloud environment, and so you're servicing not just your cloud-native applications, but also your applications on-prem. And so there you have services that from on-prem are now having to connect into your most sensitive boundary, right? That's an area of risk. A lot of times your hybrid network or your on-prem network is one of the highest risk areas for your organization. And so naturally, one of the things that we've been working towards is separating shared services into their own OU. One consideration you want to make is defining what actually is a shared services, like what qualifies to go in that OU. What additional controls can you put on that shared services OU to lock it down? And then what kind of changes are you going to need to make to existing tool sets or workflows to accommodate a new OU. But the advantages are pretty clear. It hardens the boundary around your most sensitive data, which is the most important thing. It also allows you to harden boundaries around those shared services OU. For us, a lot of those shared services are foundational to our cloud environment, so they're a little more mature, they're well understood. You can use SCPs at the account level to really lock down exactly what can and can't run in that OU. And then finally, you can create higher fidelity detections with this kind of setup. If you know a production workload should only connect to other production resources and to the shared services OU, you can alert and investigate on anything that falls outside of that scope. And the vice versa is true, right? You should never see non-prod, identities connecting into your production workloads. So it reduces exceptions, it allows you to scale more effectively, and it allows you to create better detections. So whatever data sources you have at your disposal, mine those as best you can. It might be a custom solution like we showed. You might tag certain parts of your organization or resources differently. Let's say you have a public OU where you have your public-facing stuff. You can tag those differently. You might have a rich repository of application architectures. The caveat being what's in a piece of documentation might not actually be what's running, but it's a great place to start. You might have a third-party tool like a cloud identity entitlement manager or a KIM tool. You can kind of mine those for certain patterns. And then AWS did just open source several months ago their Data Perimeter helper. It uses Athena to query logging data for certain access patterns and looks pretty promising. One part of availability is ensuring that your partners know what's changing in their environment, allowing them to potentially take proactive steps if necessary. So really put an emphasis on, getting in touch with your stakeholders and ensuring that they understand the business value and the roadmap to your controls. Make sure you have a documented exception process. Lots of the patterns that you are going to encounter are not either logged in your CloudTrail or the actions aren't actually logged by CloudTrail in the first place. So make it easy for your app teams to get a hold of you. Roll this out progressively through your environments, starting in non-prod. Again, break non-prod before you get to prod, like uncover those patterns first. And then contact your high-risk customers, make sure that they're aware of the changes and work hand in hand with them. And then continually reassess your controls, your preventatives, your detectives, your correctives, and ensure that you're actually meeting your business needs. Caleb touched on it earlier. One of the big questions you're going to have to ask yourself is, where do I want to invest engineering capacity? It's an engineering problem. Anything, you're capable of anything, but where do you want to point that fire hose of engineering capability? One of the things that we believe pretty strongly in is that security should never be the bottleneck. We should create hard guardrails and allow our application teams to do what they do best, and that is create their applications. And so we lean heavily, like Caleb said, into infrastructure as code. As part of every application, we create a pipeline role and a security path, and that pipeline role can only manage and create roles in a certain path that match the tags associated with that role. We also require every delegated role to be tagged with to have the permission boundary attached to it. And then we use SCPs to limit who can update security roles, as well as ensuring that control plane actions for many of the delegated roles are regulated. We want to see our pipeline roles creating infrastructure, but we don't want to see our delegated roles creating infrastructure. That's an anti-pattern in our environment. And so we can alert on things like that. Again, part of our reason to choose infrastructure as code and use CI/CD pipeline is that we can bake in not just industry best practices, but controls in our pipeline. The only way for us to deploy to higher environments is through the pipeline. We do not allow console access. And so a simple example here is some Terraform that creates a bucket and a key. So as part of these kind of what I will call wrapper modules, we bake in a policy that ensures that all of your third-party tools have access, they have get, list, and describe. We ensure that they're using tags, right? We use tags not just for cost allocation purposes, but for application-based access control in some of our multi-tenant accounts, right? So we can bake in these things right from the start and make it the easy path for our developers to start building. And we use open policy agent in our pipelines to kind of alert and fail build pipelines when we do not see modules adhering to our standards. You see a couple checks for some of the more egregious violations. We should never see wildcard policies in our resource policies. And then we ensure that like our buckets are always logging, right? So we ensure that we have that telemetry available after the fact if we need it. And then, as you know, one thing that we've sort of overlooked was the use of service roles in our environment. Most of our initial use cases involved pulling or pushing data to a vendor with some sort of compute. In this example, you see a Lambda that's attached to a VPC in our network. It uses an execution role to push or pull data to a trusted vendor. Again, one of the primary mechanisms here is an endpoint policy. We manage endpoint policies for about 3 dozen of our AWS services. We manage the policies and we regulate exactly what can and can be used by that endpoint policy. But when you start getting into other patterns like replicating data, that's actually, because it's the service role, the S3 service role actually replicating the data, obviously there's nothing in your VPC that's ever touched, right? That happens all over the AWS networking backbone. Endpoint policies obviously don't come into play. You're not also adding a foreign or an identity that's not a member of your organization to your bucket policy, right? So Access Analyzer isn't popping. And so one thing you really want to think about is as you structure your organization is how you're going to move data to your partners. And so think about perhaps a separate part of your OU that's kind of DMZ-like, where you regulate that S3 replication pattern. You restrict it for your whole org with the exception of that particular OU. One area that I would strongly suggest you operationalize is Access Analyzer. Whether you're a small or medium or large business, the amount of resources you're going to see is going to dramatically grow. It's very easy to get into the millions. And how are you going to analyze all of those resource policies at scale? The answer is you're not. You're not going to do it effectively, at least. And so one of the areas we chose to invest is operationalizing Access Analyzer. We have archive rules that we roll out to all of our accounts that have exceptions for those cross-account boundary violations, as well as those cross-org boundary violations. And so, a couple of examples are, the inbound cross-account, cross-org pattern from a known vendor. We want to suppress that. We don't want to see that. It's known. It's approved. The second is much more common. That's the cross-account access. You might have a lot of your third-party tools, your backup roles, your incident response roles. These are going to need access to all of your accounts. So these are going to be very common. For an organization what I would call medium size, we have about 75 archive rules right now that basically take care of all of those known patterns. So you can add one rule, roll it out to all of your accounts, and scale that way. And so it's a much better way to scale. And the effect it has is it really cuts the noise from all of your alerts. Alert fatigue is real. And so being able to suppress the known so that you can investigate the higher priority, typically, more higher risk alerts is going to be key for your security teams. As you encounter newer patterns that might need to be approved, you can roll those back into your pipeline. And finally, before we wrap up with questions, Caleb touched on a little bit, I've touched on a little bit. Really make sure you're making a conscious decision on where you're investing engineering capacity. Again, anything is possible, but using your time and your money effectively is going to be paramount to being successful in your journey. Obviously, much of the calculus is going to depend on the industry you're in, the regulatory environment, maybe your risk tolerance as a company, and your maturity. So there's going to be differences there that you need to adapt to your use cases. And then you might have tools already in the door that you're not effectively utilizing. On one hand, there's tool bloat. On the other hand, there's tools that you're not effectively using. Typically, in a lot of the tools, you can turn them on, make some checkboxes, and with a very low amount of effort, get a decent return. A lot of what we've talked about today involves, a multitude of skill sets. So you need to keep that in mind as you build your organizations. It's everything from programming skills to security background to operations background. Your tools need to be running at all times. You need to have 24/7 support typically. So as you think about the things that you're going to implement, be cognizant of the skill sets and the cross-functional skills that you're going to need to be successful. And then finally, constantly assess the impact that your choices are having on engineering. Are you devoting too much time to the low-value work, or are you tackling, the highest risk to the business? Constantly reevaluating that to ensure that you're being accurate in your return on investments to your business partners is going to be key to your future, growth. And so with that, appreciate it. Appreciate your time, and take any questions if you have them.
Thanks. How do you manage VPC endpoints? Is that centrally deployed, and then you manage policies centrally, or is that distributed? Thanks.
We manage the policies centrally. There was a great talk earlier by Meg about, to centralize or not centralize your VPC endpoints. We're kind of a combination. We typically see S3 and Dynamo in the local accounts, and we use the shared services model that AWS recommends, but the policies themselves are centrally located. And when we see new endpoints or modifications to an endpoint policy, we have automation that kicks off and applies the approved policy.
Thanks for the talk. In terms of the processes or different systems and filters that you implemented in that CI/CD pipeline for the engineers, were there any ones where you rolled them back, or you found them too expensive to implement and maybe not worth it?
The answer to your question is yes. I mean, there's always things that, analyzing resource policies at scale is hard. And so things like the hard configuration values, encryption, key rotation, those kind of things are easier. So a lot of the policy, like parsing and using OPA and Rego to do that, is a little more difficult. And so in those cases, we lean more heavily on Access Analyzer and those kinds of tools. Again, you're kind of getting into where you're going to invest, preventatives or detectives or correctives. And so we've leaned harder into that than those types of areas. There's a whole spiel about Rego that I could go into, but.
Any other questions in the room? One more.
For the resource and principal source org path condition keys, do you keep it to particular actions, such as STS assume role? Do you do it blanket across services like IAM : star, or do you do it sort of blanket across the entire account?
Yeah, it's a great question. I hate to give you like a generic answer, but to a degree, it depends. It depends on what paths we're crossing and how quote unquote restricted I would say they are. If we have like a highly restricted environment that we know we have to cross those zones of trust, we're going to get pretty specific all the way down to like the API actions. If it's more of like a promotion process, say across, say you have like a data promotion process or a deployment promotion process, we'll be a little more open there, and it really just kind of depends. So we try to be as restrictive as we can, but if we find it's a I'd say a non-restricted environment, and the app team that needs to cross the paths is evolving rapidly, and there's little risk to kind of being a little more open, we'll tend to open it up more.
Thanks, everyone. A round of applause for Caleb and Tyler.